know some of you are feeling quite overwhelmed as you start yet another lecture on a new topic in week 3. Weeks 1 to 3 are full of information in this course, and a lot of it, especially from weeks 1 and 2, we hope are a review for you. If you are finding these difficult, if you're finding it too much, it may be better that you're in Math 99, and you should talk with an advisor or your instructor before continuing any further. Because now we want to look at a whole set of videos involving polynomial functions before we finish up week 3. So you can see here, I have a very long and strange looking expression. This is a polynomial function in terms of the variable x. I know that x is going to be my variable because it's here in that notation, function notation, p of x. So a polynomial is always the sum or difference of terms, the addition or subtraction of terms. If you look at this example up here, you can see we have all of these terms that are being added. And in fact, we know that there are n plus 1 terms since we have n minus 1 all the way down to 0. So this expression has n plus 1 terms. All of those a's, a sub n minus 1, those just represent the variables. Sorry, those represent the coefficients. I'm getting ahead of myself. Those are the numbers that multiply the variable, in this case, the variable x. Now it's important to note that n, and you see it there all over the expression, n is always an integer. That means no fractions, no decimals. So n is always an integer greater than or equal to 0. So we don't want negative integers here either. And this tells me that the powers on x are always integers greater than or equal to 0. So for a polynomial function, it's a sum or difference of terms, and all of the powers on x have to be integers greater than or equal to 0. We're going to be talking about the degree of a polynomial. So the degree is always n, or the highest power. And the leading coefficient, which will always also be important to us, the leading coefficient is the number that multiplies the highest power of x. So let's look at this example here. F of x equals negative 3x to the power of 5 plus 8x cubed minus 7x squared plus 1. We're first asked for the coefficients. And remember, the coefficients are those numbers that multiply the powers of x. So we have negative 3, 8, negative 7, and 1. The leading coefficient multiplies the highest power of x. I see that the highest power of x is 5, so that tells me that negative 3 is our leading coefficient. The degree is also the highest power, so in this case, 5. We say that this polynomial is written in standard form. When we talk about standard form, we mean that it has descending powers of x. Starts with the highest power of x and goes down. And notice that there's no multiplication or division. There is only the addition and subtraction of terms. That's important if we want to find the degree, if we want to find all of the coefficients. So here's another example of a polynomial function, but it's not in standard form. Why don't you open the brackets and write this polynomial in standard form with descending powers of x. So I hope you were able to find this polynomial function. You can see that all of the exponents are positive integers. So our coefficients then are -2, 6, and -8. The leading coefficient multiplies the highest power of x. So our leading coefficient is -2. And the degree, the highest power of x, is 3.